recording all lectures and all meetups, and most of the meetups will be kind of going through the homeworks and will be more discussion oriented. This one is going to be a bit more lecture based. I will share the slides after the lecture. Cesar just asked that. And I'll, so yeah, most of the meetups are going to be just kind of more discussion based, but here I'll go through a few slides. So let me just get this here. Cool. So just to get started with quick introductions, I'm Charlie Ferrari, instructor of 608, and I currently work at Plotly as an applications engineer. So, and I've always had more client-facing engineering roles. At Plotly, I am usually working on proofs of concepts for clients. Has anyone come across Plotly or has used Plotly in the past? Cool, nice. I see some people use that. Oh, cool. That's so in the Python class, that's exactly Python doesn't really have a Hadley Wickham who maintains ggplot. So it's really we found a lot of more users are on Python than on R. So I currently work there. We will be using Plotly a lot on the Python side as well as on the JavaScript side. So we will be getting into some intro JavaScript. And then just in addition to that, a few other things that I do. I used to work at an economic forecasting company, helped support the econometric package eViews, and I like to get involved with the New York civic hacking community. So this image here is actually of a project I worked on where I was looking at New York City cab data. And so this is sort of looking at cabs finishing at subway stations, looking at informal cab share systems. So you kind of see there's a pattern on that's 108th Street, but you could kind of see some patterns emerging on some of the streets there. So just to quickly introduce this class is really just about presenting information and using technology to help in that process. So in previous classes, obviously, you're using data visualization in some cases, but this class is really going to be focusing on what that means and what are some best practices when you're performing data visualization. And one thing I like to sort of characterize as well is in terms of the tech. We'll be starting out in R and Python, but we're also going to be moving on to some light JavaScript towards the end. D3 is pretty much sort of one of the standards for data visualization in JavaScript. Plotly is actually an abstraction of D3, so it's D3 is really core to data visualization on the web. And I'll introduce D3, but because obviously most of you guys are sort of working in R and Python and may not be are probably not coming from a web development background. I'll try to keep it light, and I'll try to provide as many escape hatches as possible. I actually just saw in the chat here that someone used Bouquet. For homework 2, actually, I'll be bringing in bouquet. I haven't posted it yet, but it's a package called Data Shader, since we'll be dealing with big data. So that one should actually be pretty fun. I'm just working out a few kinks in the questions there. And then just in terms of general class info, class dates are all in the syllabus, and homeworks are due every other week. So really functioning more as projects. And at the end of the semester, there will be a larger public project. I'll post it. I believe information about that should already be up there. If not, I'll post it shortly. But it's essentially, it'll be in the similar grain to the projects leading up to it. You'll be picking your own public data set and really coming up with your own, your own kind of story with the data. So you'll find a data set. As we go through the class, I sort of try to focus on really the communication aspect of data visualization. So being sure that you have kind of a not thesis, but for lack of a better term, thesis, and then really use that to inform your visualization. And also, the course GitHub link is here. This is primarily going to be using GitHub for the homework assignments. So just if anyone in the chat hasn't used GitHub, just chat there. And I assume most people at this point have had some experience with GitHub. It really does help with the submission of assignments, and especially given sort of a lot of the structure, it kind of becomes you clone a GitHub repo, you work within the template that's provided, and you're sort of pushing your own changes to that. So as you're moving on professionally, that's going to be pretty close to the sort of workflow that you'll be following. So with that, we'll just get into some visualization technique and theory. So is anyone familiar with this picture, or does anyone know what this is? Yep, it's the Challenger. So this is a picture of the Challenger disaster, and Edward Tufte actually, and this is actually just more photos here. So basically, the Challenger disaster was one of the first major disasters to affect NASA in this way. And here you could see specifically what was causing it. So if you'll notice in these pictures, there's a little arrow pointing to the pointing to some kind of black coming out, and there was it was essentially a fuel leak that caused this. And Cesar mentioned O-ring. That's exactly what it was. So there are these things called O-rings that are holding the rockets together, and it was at these points that there was there were failures. And Jose mentioned 1986. I believe this happened in 1986. I forget the exact date. So basically, this was used as a key example in one of Edward Tufte's books, and from Visual Explanations, actually the one I just showed you guys. So when the engineers were sort of working on safety precautions and how to, what to watch out for, kind of giving the okay for this launch, they were referencing something that looked like this. I believe this is actually from this is from their technical specifications. So looking at this is basically looking at, and I'm sorry, this is actually looking at a bunch of test runs. So So you could see a few tests. There's on each rocket, you could see, or on each sort of double fuselage, you could see what the temperature was on the day of the test, and then you sort of use lines or black shades to sorry. So you have black, lines or black shades to kind of demark where there were O-ring issues. So just looking at this visualization, does anyone notice any pattern at all, or are you able to kind of you're able to obviously get the raw data, and you're seeing where there were failures, where there weren't failures. Um, exactly. Asher just mentioned it's perfectly incomprehensible. So you could see that while all of the information is there, nothing's factually incorrect. It's just failing as a data visualization. Nothing here really gives a clue as to what the pattern is. It's just simply a list of trials, basically. Yeah, in the chat, if anyone knows what SRM stands for, I actually don't. So if anyone could see that. So Edward Tufte proposed this visualization as something that would have done a lot better and would have really shown what the pattern was, and why the particular date chose, January 27th, was a bad day. So first of all, this is from Cape Canaveral. So in terms of temperature variations, before I get there, temperature on the x-axis. So and sort of the O-ring index on the y-axis. So it's kind of giving some information about the quantity of damage and the temperature. And this is taking place in Cape Canaveral. So that's Florida. Usually is going to have great weather, but it seems like it was just very unseasonably cool on this particular day. So marked, you could see the range of forecasted temperatures that were on that day. And then in terms of the actual data, you can now see what the pattern is. So you see as temperatures are falling, in the beginning, there's not really that much of a pattern. You have one or two sort of incidents, and it's something that wouldn't really show up statistically. There's not really enough data points to really get something like really. If you wanted a robust statistical analysis, you would need to try things out at all temperatures and see what happens. But despite the sparsity of the data, you could still visually see what's happening. So you have this, you sort of have over here like one or two accidents, and then as you get to lower temperatures, it becomes a bit more consistent. And on the coldest day that was tested, you could see that you're ending up with a lot of major failures. So, visually, this suggests that if you are, as the temperature is going down, you're going to sort of have some trouble with the O-rings. And looking at it this way, it makes that point very more clear. Whereas here, it's just not. And obviously, that's not the only example of bad visualization. So here you could see these are just a few horrible visualizations. Things like pie charts not adding up to 100. For the bottom right, the bar chart there, can anyone guess why that, or can anyone see why that's a bad visualization? Scaling, exactly. Non-zero axes, they're not always bad, but with bar charts, they are always bad. And you could see why here. The bars are kind of indicating that this visually, it's being indicated that this is around twice as much as 1998. whereas in reality, that's not what's happening. So the scaling is way off here. And then just a few other bad visualizations. So things like with these lines here, you just have way too much noise. There's no way to really discern anything from that. And then just to summarize some goals of data visualization, it's really meant to, and you could kind of see the pattern of all of these. It's about communication. Data, data's data. You could see a list of data points, and technically that's, sort of that's factual. But humans are more visual thinkers, and there are a lot of well-established techniques to really get sort of points across visually that you just wouldn't really be able to with data alone. And then we'll go through three main visualization strategies today. These are really kind of the major ones. We'll go through a lot more in the discussions as we're sort of going through them one by one and sharing examples. But for here, really, we're going to be focusing on just matching the display to data and purpose. And then the last two are sort of core Tufte principles. So we already in the discussions talked about information to ink ratio, and I believe next week is principles at small multiples. So these are two kind of strategies to working with data. So in terms of matching the display of data to purpose, what this is really referring to is the fact that there are different forms of data, and depending on the form of the data, there are different strategies that you could use to visualize it. So I'll sort of be going through these, sort of just different types of data, but this will also sort of turn into just sort of mapping aesthetics, if to use sort of ggplot style language. So the first two we won't be covering that much in the course. The first two, these are sort of relational and spatial. Vast majority of data that people are working with, it'll usually be tabular. But these are, it's just important to know sort of what these types are. So relational, you have sort of links between points, so things like family trees, international trade, things like if you're looking at sort of the fork and edit history of GitHub, and you're tracking projects, that's a relational data set. And for spatial data, it's a bit more based on an intrinsic position. So this is different from kind of a scatter plot or any other data plot where you're sort of mapping X and Y, because with spatial data, the position is more of a tangible thing. So if you're mapping X and Y, you're able to choose that framing, and it's based off of, it's sort of related to the data. With spatial data, you don't really have a say in what longitude and latitude is. Longitude and latitude refers to a specific point on a map. And so obviously maps are the sort of best example here. But you can think of some other examples, things like star maps, which still map, but if you're sort of mapping, if you're looking at stars in the sky and you want to position each of them, the actual position is what matters, and not, it's very much related to that. And then for tabular data, there's quite a few different types. So here you could see just the way that the divisions work. You could think of data as being categorical, discrete, or continuous. So, and this, I imagine most people sort of in past classes would have come across this before, where you're, dealing with sort of numeric data versus classifications. So classifications would be categorical data. So here you can see like fruit, apples, oranges, strawberries. What it's sort of more used about sort of classes of things, and then discrete and continuous are kind of both lumped under order. Discrete is a bit more comparable to categorical, in that it's non-numeric. So as an example, these are just clothing sizes, and it's so it's similar to categorical, but it's the order still matters. So for discrete ordered data, small, small, medium, large, extra large, the order of that matters. Small is smaller than a medium, is smaller than a large, etc. And then the last being continuous, like that's just numeric data. So anytime you have numbers, unless you are using those numbers as categories, it's going to be something continuous. So the example here, like it's usually sort of mapped to a unit of some sort. So something like 5 kilos, 25 degrees, things like that. That's really what's meant by continuous data. And then for each of these data types, there are a few strategies of how best to display, how best to sort of map your data relations. So for spatial data, maps are really the way to go. That's pretty much the sort of tangible relationship between the points that you're looking at. For relational data, there are a few different ways to work with it, and this information here, this is actually coming from Munzner, and I'll go through. I'll post her slides, and I'll just to note, like these concepts are sort of really spearheaded by her. So this is really just about it's in order of what is really what is more impactful. So, essentially, like when you are looking at a data type and you're trying to think of a strategy for it, it's really about the sort of, try to stay as much to the top of these lists as possible. So in terms of relational, you have things like contain. So that includes like Venn diagrams, which would be displaying relational data. And connect, which is actually what we were using here. So this is sort of using the connect approach to displaying relational data. For ordered, you could see things like position, length, area, and again, these are sort of decreasing, sort of in order of decreasing impactfulness. So it's kind of using an example here. One sort of major flaw that's been pointed out of pie charts has been that they rely on area. And if you think of it, like picture a bar chart in your mind and picture a pie chart. Especially picture a pie chart where you have multiple, like a large number of slices. And in a pie chart, it's, especially when you have a large number of slices, it's difficult to really grasp what each slice is referring to. You may see different, you may like see what percent labeled, but it's not making that direct visual connection to your brain. Like if I were to say, is this square twice as big as this square? You're not able to really easily grasp that. But with length or height, it's different. If I showed you two lines, in this case, like a lot of people would probably say that the shorter line is around 3/4 the length of the larger line, and that's pretty easy to see. You're able to pretty quickly grasp that visually, and position as well. Like you're able to pretty easily see that in relation to the line, the upper point is half as close as the lower point. And then in terms of categorical, position again is really useful. So this is sort of groupings of objects. But usually I would say color is kind of most commonly used here. So when you are looking at kind of data where you have a numeric component and a categorical component, color is really useful to distinguish the difference between them. So, if anyone's familiar with the Gapminder graph from Hans Rosling, he's sort of mapping out on X and Y what the life expectancy versus GDP is, and he's coloring by continent. So continent is showing the categorical difference between each of the continents. So the graph that I just highlighted over, I kind of purposefully, just showed it quickly. But if anyone sort of were to just kind of make a theory as to what was being shown there, what would you guys say? So obviously I showed it very quickly, so probably didn't get the context at all. But if you were to, if you wanted to describe that to someone based off of what you saw, what would you highlight? Just show it one more time. So in terms of what is really most impactful about a visualization like this, if I were looking at this for a split second, if sort of the first thing that pops out to me is just the overall shape of the line. So even if I didn't know what the concept was, I would have been able to say something's going up and then it goes down. It looks like a boom and a bust. And in that case, that's really what's being shown here. This is looking at sort of housing prices during the housing bust. So you could see that the housing prices are sort of the most important. That's really what's visually the most striking. Cities are sort of next on the list, so that's being shown on the right there. And then you could see time as kind of important. And what's more important is kind of the concept of you're moving forward in time, but really it's more sort of providing the context of this is taking place during the housing crunch. And I find it useful also to kind of map these back to kind of pseudocode. So this is using ggplot grammar of graphics to really describe what's happening here. So the grammar of graphics, it's really taking place in the AES. And that's really what's mapping out the columns if you're in a data frame, just mapping things out to your variables. So next, the next concept to go through is just maximizing information to ink ratio. We had a lot of interesting discussions on this in the discussion board, so a lot of people were giving this some thought. And really what this is meant to do is just really kind of be concise. You could see this as sort of the comparison to concise communication. And and really, when you remove distractions and distracting elements, it makes the main message of the graph a lot more clearer. In some of the examples that I've posted for this and chart junk, you could kind of see that there's varying degrees of distraction. You could have distraction that is actually actively detracting from value, or you could just have distraction that is meant to add a flourish to a graph and isn't really, isn't providing, it's not detracting, but it's not providing any meaningful information. So what everyone should be focusing on is when you do have a situation like that, tend towards removing those distracting elements. And it also helps you really think about, when you are making a visualization, what is important in this, and it kind of helps guide you in your visualization choices. And lastly, we have the principle of small multiples. So if you remember in the bad chart slide, I had the example of a lot of lines that are plotted over each other, and you weren't able to really tell what was going on. But here, you're able to, by looking at things next to each other, you have more of a guide. You're able to actually compare things more directly. In particular, if you're looking at stock prices, you have to deal with differing scales. So, in this case, BlackBerry is just on a different order of magnitude than any of the other charts. But what matters is its behavior in its range, not the absolute value. So when you're looking for patterns, it makes sense to view it like this. And again, this is just sort of going through how the grammar of graphics really helps define things like this. So in this case, you have your same AES, just mapping your X and Y, but you also have a concept called facet wrap. And that's what's really allowing you to take a variable and say, my data, a categorical variable, because you want to divide it up into a set number of classes. It's a way of taking that variable and saying, I want to just look at my facets in this way. Or one other way of dealing with this is just making sure that your measures are comparable. So going back to sort of the stocks, if you did want to view all of these on the same set of axes, it wouldn't make sense to include the absolute values. But if you did the percent change, it would all be starting at one point, and you're able to make sort of the same comparisons that you would with small multiples. So, this is functioning a lot better than looking at two y-axes in this case. So looking at it in practice, you could kind of see, a lot of these sorts of spark lines are used out there. Like, this is an example of looking at different, different portfolios, different index funds. So looking at the looking at this table, you could kind of, is there one that kind of stands out as being different from the rest? Anyone who works in finance might be able to pick it out by the names, but otherwise, you could just use the spark lines to see if there's anything that is sticking out.
Yeah, the PIMCO one is down.
Yep, that's correct. The PIMCO one is the odd one out, and that's actually a bond fund. So it's the others are collections of stocks, and it's you could see that it's behaving in a different way. So, and you're able to pretty clearly see that just by looking at spark lines in that way. So, so moving on from that, so this is another sort of leader in the visualization space, Scott Baronato. I'll include a link to a talk of his, and this he kind of reframes a lot of the strategies that we're talking about. So, so here you could almost think of it as kind of the conceptual version of maximizing the information to ink ratio, where it's really you're thinking of a specific point that you have to get across, and your visualization choices are really informed by that. So here, this is just an example of sort of looking at a block of text. You have the stats there, so all of the data is there, but it's there's only so much that you could really provide. So here you have you're using a lot of words to get your point across. And if you chose instead to use a visualization like this, it wouldn't be anywhere comparable to the amount of ink that you were using before. So here, this is actually even, you could think of this as kind of even one step beyond spark lines, where if you're looking at kind of a start and an end point, and what matters is the growth between them. So you're more focused on, in this case, it's just a difference of a year. But if perhaps you're trying to show that something increased by X amount over the past 10 years, and it's less important the volatility during those 10 years, but what's more important is just where you started out and where you ended up. And that you could see here. And I've actually been seeing a lot more of these sorts of visualizations around, where it's particularly in the upshot from the New York Times, where you could kind of see like this really paring down to sort of even beyond spark lines. So here, this is sort of another example of what could be sort of what this looks like in practice. So here we have, we're looking at vinyl sales, so sort of large records, which were sort of the only way to listen to music back in the 70s, but now have just become really popular, and here I'm making the point, popular among hipsters. So here, if I have a visualization showing the data going back to 1993, I'm making the claim that this was really kind of unprecedented. That that this is just being driven to new highs. And so we'll hold off on this for a second. I want to just go off on a tangent to some other ways that you could kind of look at a concept like this. So this is actually, this happened just earlier in January when Trump was at Davos. And in this case, Trump is talking about GDP. So don't read through this whole thing. Maybe just skim for a couple of the points, the data points that he's mentioning. But he's basically talking about GDP and comparing himself to Obama. So some of the key things that he's mentioning, he's saying that he when Obama was president, GDP growth was heading in the wrong direction. GDP growth is high now that he's in office. So what I did was I just took each of the data points that he mentioned. So he mentioned 5 data points here, and just sort of simplified that into a visualization. So here we have we're comparing Obama and Trump. We have different levels of GDP growth, and that's just sort of shown here. So the main message is the economy. The economy is doing better under Trump than than it was under Obama. Um, and the question is, would you consider, is this considered a lie? And it's we have a never lies there in the chat. Um, but it's you sort of ask a question like this, and when you really think about it, it kind of is a bit more weighted than just did he lie? Um, so it sounds kind of trite to say, but when you really think about it, like what are we really referring to when we're talking about a lie? And I sort of there are a few different ways that you could look at this. If he mentioned the wrong numbers, that's very obviously a lie, but all of the numbers were correct. He mentions in the tech, he mentions like as he's talking that it's been a long recovery. It has been a long recovery. Since the Great Recession, it's kind of been slow and not super growth, but kind of a long recovery there. During the first 2 quarters he referenced, were we going in the wrong direction? Just looking at those first 2 quarters, we were, or those 2 quarters, we were. So it kind of makes it hard to pin down based on these definitions. Seems like this isn't a lie. So here, this is looking at things in a larger context. So I actually this is just a screen cap from there, but this is GDP growth since 2009. And here you could look at the, sort of the context that this is all in. So those numbers are correct. In those 2 quarters, growth did decline. But when you're looking at the full context, none of that really matters. It's all within the variation of the natural variation of GDP growth for the past 10 years. So just kind of really parsing what Trump is literally saying. He's looking at economic growth in Q4 2016 and Q1 2017 were lower than Q2, 3, and 4 of 2017. But what Trump is doing is also he's allowing his listeners to imply things. So he's allowing his listeners to imply that economic growth in Q4 2016 and Q1 2017 are comparable to every quarter under Obama. Trump has already delivered 3 quarters of higher growth and will continue to do so. So when you're actually looking at something like this, it's not a lie, but it's kind of more insidious than a lie. It's sort of carefully framing statements that sort of allow listeners to imply specific things. And when you are trying to evaluate what you're hearing, asking if a statement is true or false isn't enough. If you look at fact checkers out there, you could do that forever, and that's really not enough. Like what you really need to do is be constantly aware of the information's context. And sort of a good rule of thumb is just if something seems like it doesn't make sense, if it seems unbelievable, just take a step back, widen your context, and see what that change is. And obviously, this isn't a new phenomenon. So this wasn't really from an official source, but I don't know if anyone else reads as many economics blogs as I do, but I've seen this visualization around multiple times when looking at sort of the early days of the recovery and comparing Obama to Bush. So what this is looking at is job growth over the Great Recession, sort of during the recovery, like initial days of the recovery of the Great Recession, and colored by whether it's Bush or Obama. So looking at this graph, Can anyone point out when jobs begin to grow again? I didn't even realize this had a name, the bikini chart. Kyle mentioned this in the chat. Yep. So, yep. So you guys were. So Pavan mentioned that it was November '09, and that's absolutely correct. Um, so job growth doesn't begin until November '09, but the visualization is really highlighting something different. It's highlighting essentially things were going down under Bush, things are going up under Obama. If you wanted to be really precise, you would say the rate of job growth, the rate of job decline has decreased, but that really doesn't sound as convincing as goes down here and up here. Um, so with that in mind, I think it's obvious now what's happening here. So if you are, so here I make the claim that it's really unprecedented what's happening in recent years with vinyl sales, but looking at it over the past, it's nothing compared to what was happening in the 70s when vinyl was actually the way to listen to music. So you could sort of see that trick being used in a non-weighted way here. But this is obviously all over the place. When visualization is about communication, and communication is really about sort of starting with everyone is data everyone is data driven, but you also there is also a degree of there's a point, and sort of the data is supporting that point. So this is going a bit back to Munzner, and we have a couple of minutes left, so I'll just kind of breeze through these. But here, this is just looking at kind of what people sort of react to with their senses. So this was touching on what I mentioned before about length and area. So here you could see like length, it's a perfect one-to-one. Like if you see two things, something, if something is twice as long as something else, it'll look twice as long to you. Whereas with area, if something is so this n is referring to sort of what you're perceiving versus what reality is. So with area, if something is twice as large as something else, you'll perceive it, just multiply that 2 by 0.7 and you'll receive it by less than twice as large as something you're comparing it to. And most of sort of a lot of these you could use for data visualization. Electric current would be kind of scary if you did, but if you did, just keep in mind that's 3.5. And then just lastly, kind of some general tips about discrimination. So here, pie charts, I mentioned how in general, there's, in general, like you don't want too many categories in a pie chart because of the area problem. This is just kind of some general rules of thumb. So basically, I'll just skip to the end here. So these are a couple of the authors that I would recommend checking out. Tamara Munzner was really sort of highlighting the kind of sort of perception end of things and really looking at how that works. Whereas Edward Tufte is more sort of focused on I want to say like the artistic, sort of the more design elements of data visualization. Jacques Martin is kind of an older sort of founder of the sort of original thinkers on data visualization. And Mike Bostock is one of the newer ones. So he created D3 while he was at the New York Times, and actually just recently came out with some really cool online notebook tool that I might try to integrate with the course later on. So we're pretty much at the end of the meetup, and I wanted to spend some time just sort of looking at the homework and seeing if anyone had any questions here. First of all, I assume everyone has like R set up and sort of old hat at kind of looking at an R markdown, right? Classes will be, Jose asked if classes will be ending at 7:30. They will be. It's actually the second session that starts at 7:45. So basically with a lot of the homeworks, I'll be sort of I'll try to, as much as possible, include a template that you guys will be able to work through. So here, you kind of have just sort of space to answer each of the questions. R Markdown is great. You just click knit and it gives you sort of a document like this. And with that, like you could just sort of submit that as your homework. But like I mentioned, sort of keep submissions in your GitHub. And when you are submitting it on Blackboard, just include the link of where the particular folder is. So in terms of just the data that we're looking at here, this is looking at Fortune 500. I believe it's the 5,000 fastest growing companies in the U.S. So here you could kind of just see some preview of the data. And the questions are all sort of framed around inspecting this data. So this is meant to be more of a kind of exploratory exercise. When you're working as an analyst and you have, obviously you have business questions to answer. This is the sort of, kind of procedure that you would follow. And I imagine, like, unwittingly, most people have been doing this for a while now. Like when you're, if you're taking any of the more, model building regression courses, there's a lot sort of to start out with in terms of exploring the data, checking which variables are correlated with each other, getting an idea of what the best technique is to use. So that's pretty much what we're doing here, except we're doing it with more sort of standard business questions. And one other question, because for homework 2, we will be moving on to not moving on. We'll be going back to R for homework 3. But does anyone, in terms of everyone's Python experience, has everyone set up Jupyter notebooks? I believe in 602 they end with sort of working in Jupyter. If anyone hasn't, mentioned, like, just sort of, okay, so I see at least one person hasn't. So I would recommend, like, in between working on the homework, Spider, okay. Anyone who took 602, was it required to do Jupyter? Yeah, so Michael Mueller mentioned this in the chat that if you do have Anaconda installed, which is a Python distribution, then Jupyter will be there. So I would recommend kind of getting started early in terms of at least making sure that that you have Jupyter running. Because for homework two, for project two, we'll be using a package called Data Shader. So we'll be sort of looking at, and this is really in service of looking at larger data sets and visualization strategies with them. So, so yeah, that'll be, Jupyter will be required for that. So if you do have Spider set up, then sort of get started on getting Jupyter Notebook set up. The good thing about Jupyter Notebook, though, will be you will have a template similar to this. So when you'll be able to just pick up the template and work within it. So it's there might be a bit of setup. Like Jupyter, you have to start from it from the command line. So you just run Jupyter Notebook, and it'll open it up in a new browser window. And that's sort of just a quick intro of that environment there. But so for those who don't have Jupyter set up, just sort of try to at least get like some Hello World stuff before project two. So any other questions on logistics or anything else about what I've gone through? Cool. So so it looks like we're just out of time. So thank you everyone for attending, and I hope you guys have a good night or good whatever time zone you're in, right? A good day. So thank you, and good luck in the course. Bye.